Hello, and welcome to Balboa High School, New Jersey style. I'm going to talk about concave lenses because we didn't have time for it before the bell rang. Concave lenses, you guys remember, it caves in. I usually remember it like that. Caves in, usually we're going to talk about caving in on both sides. In reality, you could have a lens that caves in only on one side and is flat on the other, or even convex on the other side, but why do it? Because it's not in the text. Now, if you guys remember, this is my mom laughing, if the light goes in horizontally, in the middle, it goes straight through. On the edges, instead of focusing on a point, it goes away from an imaginary focal point. Focal point. So this is how you draw it if all the light is horizontal. This is supposed to be horizontal. But how do you do it if you want to find out an image? So we're going to do an example. And we're going to even start with a brand new piece of paper because I'm wasteful. Concave lens. Let's do concave lens of focal point of -3 centimeters. Remember, it's negative because it's imaginary. It's not really focusing there. It's focusing away from there. And let's say our object is DO is 6 centimeters away. So we're going to put our line in the middle and 6 centimeters. 1, 2, 3, 4, 5, 6. We're going to put our little arrow 6 centimeters away. So this is our object 6 centimeters away. So the first line, ray number 1, is a horizontal line. But then unlike the convex one, it doesn't focus on a point. It goes away from a focal point. So it goes away. I'm even going to draw the dotted line. Goes away. So the solid line is what the light does. You can even make it blue for light. And the dotted lines is imaginary. You're imagining that it's coming from this point, 3 centimeters away. The second line goes straight through the middle, just like the other kind of lens. Eek. 2 rays, ray number 1 and ray number 2. Now, do these rays hit each other? Mike?
No.
No, they don't, my audience. So the 2 rays go away from each other, but they look like they're coming from this point right here. And I'm going to make it in red. They look like, if you backtrack, if your eye is over here, and this is going to be a very scary eye. Ready for the scary red bloodshot eye. There we go. If you're looking right here, it looks like those rays are coming from right here. So here's your image. This is what you see. Now, if you have glasses, you want to see an image that's closer up because you can't see far away. And that's why you do it. So this is the ray diagram. Ray number 1, straight horizontal, away from the focal point. Ray number 2, straight through the middle. You get your image. Let's try the equation and see if it works out. And what I've gotten is, it looks like it's about 1.5 centimeters away. Now, it should have been about 2 centimeters, but that's because I can't draw very well, and I didn't use a ruler. Okay, so let's use the equation. The distance for the image equals 1 over the focal point minus 1 over the distance from the object. Notice that this one's negative. This one is automatically has to be negative. So we are going to do 1 over -3 minus 1 over 6 equals -2 over 3. Oh, sorry, -2 over 6 minus 1 over 6, -3 over 6. DI is -6 over 3 or -2, which means that the image should have been at 2 centimeters instead of 1.5. But like I said, when you're drawing it, you get an approximation. You don't get exact numbers. And last part is this image bigger or smaller? Well, it's closer, so it should be smaller. And the magnification, how much smaller? How many times smaller? It started at 6 centimeters. It ended at 2 centimeters. So it should be, it's 3 times closer. It should be 3 times smaller, which approximately looks 3 times smaller. Like I said, when you draw these lines, you don't get exact numbers. You get approximations. If you got it at 1.5 and it really should be 2, you did good. If you got it 1.5 and it should be 7, you did bad. So that is concave lenses. And basically, let me do one more example, one where the focal length is bigger than the distance. And you see it's the exact same thing. Actually, concave lenses look scary, but easy to peasy lemon squeeze. Okay, one more example. Example 2. Example 2. Let's make the focal point. I like 6 and 3. So let's switch them. The focal point is -6, and the object is at -3. Same numbers, we just switched them. So we draw our lens. Looks like a big eye. We mark it off. 1, 2, 3. There's our object. Oops, I made a mistake. I made this negative. This shouldn't be negative. You can't put an object in a negative thing, or you won't make an image. Positive. Oops, I forgive myself. 1, 2, 3. There's our image. Oh, maybe you should make it bigger. Bigger. 5. 1, 2, 3, 4, 5, 6. There's our focal point. So ray number 1 starts on the top, horizontal. I'm going to make it blue. Hold on a second. And then away from the focal point. And ray number 2 is right through the middle. Oops. And then we're going to backtrack, and they meet right here. And this is your new height at 2 centimeters. So we're going to go back to the equation. And it's actually the same equation, we just switched the F and the D. 1 over DI equals 1 over the focal length, -6, minus 1 over DO, minus 1 over 3, ends up being DI is still at -2 centimeters. So the position of the image is the same. The only difference is, now you went from a distance of 3 to a distance of 2, so your height is 2/3 as big instead of 1/3 as big. And that's the end of concave lenses. Okay, thanks very much. Bye.